So, Hasselblad's history. The camera division was set up in 1941 in Gothenburg, Sweden, where it is to this day. We've moved around various factories, but it's still in the same city. And the first camera that we actually made was an aerial camera. The Swedish government approached Hasselblad and asked them to make a copy of a German reconnaissance camera. Victor is recorded as saying, "No, but I can make you a better one." But actually, Victor's main passion was bird photography, and he was looking for a way to get high quality images, but he needed a smaller, lighter, much more portable system than the huge, large format system that he was used to carrying around. So he started looking at design functions and changes. What could he do to give him his perfect camera? So we can see here the first model of his ideal camera back in 1943. Very, very small considering, and Victor had already decided to use 6x6 film. So that was the main constraint in terms of the smallest that he could go. So by the mid-40s, we're looking at the 1600F in terms of a wooden model for handling, etc. And that led by 1948 to the release of the full edition of the 1600F, Hasselblad's first consumer camera. And you can see here, looks very, very similar to later V system cameras, so very modular, lens there, detachable 6x6 film back, waist level finder. So it's got all the hallmarks of the classic Hasselblad system. So by 1957, we'd gone through from the 1600F, the 1000F, and we came out with the 500C. And here's an image of one of those, and it's probably the most iconic, if you like, when you ask somebody about a V system Hasselblad, the 500C is the one that they'll probably mention. The 500C also was the start of another relationship, which was Carl Zeiss. So the legendary lens maker, it was also a shift from us to an in-lens shutter. So right from the very start there, Carl Zeiss with in-shutter lenses, great combination, and so much so that NASA contacted Hasselblad to use our cameras in the space program. Now, you probably know that we obviously went to the moon through the Apollo program. We'd been in with NASA from the very beginning in terms of Mercury programs, Gemini programs, all the way through, but it didn't stop with the Apollo missions. So although we've got hundreds and hundreds of fantastic, mostly iconic images from the surface of the moon and in space, obviously, beyond that, we then went on to missions like SKYLAB, where the standard Apollo cameras were used. But as the space shuttle missions came on stream, we designed specific cameras which were a little bit more user-friendly within the cabin of the space shuttle. So you can see here the motorized versions of the 500s, data recording devices, still got the large film format, film backs, and the reversible viewfinders on top. So here you can see one of those cameras just in standard use on the shuttle, capturing images of the Earth, many, many images, different lenses in use up to the 250, some wide angles, etc. These cameras were mainly used within the actual space shuttle itself, shooting out of the windows. So they were used to capture, images like this. So the launch of the Hubble, the servicing missions, the resolution of the camera allowed with the 6x6 film allowed them to actually capture fantastic images like this. So continuing through, the cameras were still in use, even as the ISS was beginning to be set up. So all the way through there, all the way through to International Space Station, full setup and in use until 2005. At 2005, the last cameras in use came down from the space station. And obviously at that point, digital had moved on, much more compact cameras. And unfortunately at that point, medium format digital cameras were not exactly easy. You had to shoot mostly tethered in the early 2000s. So that was one of the reasons why the shift was made to a smaller format. If you want to know more information, deeper information, we do actually have a full Hasselblad in Space webinar that's available on the YouTube channel. So please take a look there if you want to see more information. But moving back quickly to the full V system, you can see here all the way through until sort of mid-2000s with the 503 as the last model. A real selection there in terms of motorized models, the SWC for a compact model, flex body, so a whole range of different styles and uses. With the invention, or the culmination there at the 503, using the digital backs that were available, at 2002, it was time to move on. So looking here at our milestones from all the way through 1941, with the HK7, and then 1948, the first consumer camera, you can see film all the way through, including the X-Pan in 1998, and then H system comes along 2002, and from then on, the electronics improved, the sensors obviously update, and by 2014, CMOS is available in medium format. And then that brings you pretty much up to date with where we are now in terms of 2016, we released the H6D. Again, big technology changes in terms of CMOS sensors, USB 3, Wi-Fi connections, and so on a medium format camera. 2016 also saw the launch of the X1D, and obviously we're going to look later on at the successor to that. Just briefly want to look at why Hasselblad. What's the difference? What are the things that make Hasselblad different from others? If you like, our core is that we want to create cameras that are tools to do the job, not full of bells and whistles that you don't really need, but are technically very superior, clean design, do the job, but most importantly, they are not a tool that gets in the way. So it allows you to concentrate on your picture taking experience and not worry about what setting, what button, etc. So our main philosophy points: image quality. That is probably the core of Hasselblad's philosophy. Image quality comes first, whatever, and that comes down to sensor output, lens design, optical quality, leaf shutters, the software we process, and the color space and so on that we work within, which we'll look at later. But image quality is our core. As I said before, the design side of it, it needs to be very clean design. Obviously, if you need dials and buttons to do a specific function, they'll be there. But we won't add extra buttons and dials and so on just for the sake of it. Very streamlined design, even down to the menu structure and accessing the functions within that electronic system. Precision mechanics. So where possible, all parts are metal. The camera itself is designed to have or endure, should we say, a hard life. You know, it's designed to be there as a tool and used. And so we go to great lengths to make sure the components that are in the systems are reliable, long-lasting, and you know, from a user's point of view, it means you've got to get a camera that will last you many, many years with trouble-free use. I suppose the final one is the Hasselblad community, and this is a way of owners, plus obviously workers for the company, to come together, share our experiences, talk about how to get the best out of the equipment, share the results. And by doing that, everybody learns, and we see the rich history, and also expand people's knowledge of the company and how to get the best from its products. A little bit like what we're doing today. So very quickly, I'm going to talk about the, if you like, flagship products, which is the H6D system. The current H6D, if we list the main functions of the camera, dual media card slots, so an SD card for compatibility, a CFast card for high-speed recording, which is really useful if you're doing 4K video, raw to card. Again, the CFast gives you the edge in terms of transfer speed. We've also got a USB 3 Type-C connector built into the camera body. Shutter within the lenses is anything from 1 hour to 2,000th of a second. Obviously, live view it's a must these days. 30 frames a second live view with focus peaking. Choice of video. So again, if you've got the 50 megapixel sensor, you can get HD video. If you've got the 100, you can do 4K, and you can do 4K RAW. The rear display itself is a touch interface 3-inch display, very much like a smartphone in terms of double tap, swipe, that type of functionality. And we'll look a little bit in depth at that a bit later on the X1D. Other connections, obviously, mini, HDMI, audio in out, Wi-Fi. There's also within the grip, there's connectors for remote release, etc. So all of the general connections and controls that you would expect. So the sensor options. So the 50C has a 14-bit color depth with the 50 megapixel sensor and a 14-stop dynamic range. Same sensor that's in the X1D. The 100C, obviously larger chip. True 16-bit output and 15 stops of dynamic range. You can opt to go for a 14-bit color output and a slightly smaller dynamic range, but the benefit being you do get a smaller raw file size. In terms of lens kit, system was launched 2002, and we've gradually added lenses over the years, even Mark II versions of certain ones are the most popular lenses. And so currently there's 12 lenses, and they range from 24mm all the way up to the 300mm. There's 2 zooms in there and a macro lens. Additionally, there's plenty of accessories in there in terms of HTS 1.5 to allow you to do some basic tilts and shifts, and you can use any lens up to 100mm focal length on that. We've also got the classic extension tubes, macro converters, and so on, which is what you would expect for a system. Moving on to the main reason that people buy the H in terms of the flexibility side of it is the modularity of the camera. So you can see here multiple components that are easily swapped and changed. So choice of viewfinders, so waist level finder, obviously most people use the prism finder, but you can also have no finder. So if it's on an aerial type situation, then you can have no finder at all. You can remove the digital back, and you can put the standard 645 film back on. And if you can find the instant film, you can even use the HMI 100 instant back. The digital back itself can also then be attached to a whole range of technical cameras, and that can be, Lindhoff, Alpa, many options there. Mechanical shutters, electronic shutters, the full range. Again, more detail available on request, but this is the way of getting access to a whole range of wider movements where required. Our most specialist camera is the multi-shot, the 400 megapixel. Now this particular camera, it's a 100 megapixel sensor inside, just like the 100C, but we physically move the sensor in small increments. So as you're all probably aware, the sensor itself is covered in an RGB color filter array, and normally each pixel's data is made up from a range of data from surrounding pixels, and it's interpolated, guessed basically. So with the multi-shot, if I was to take a 4-shot exposure, you can then get true RGB. I'll go into the details in a second, but these particular products are used for where high resolution is required, so fine art, restoration, preservation, but also things like medical, industrial. So high resolution, color accurate reproduction is where this particular camera would be used. So as I was saying, with the 4-shot, we physically move the sensor in 1 pixel increments, so 4 times, and so therefore we get true RGB data for each pixel. So that gives you probably a 25–30% increase in resolution in terms of color for each pixel. We can then go to a 6-shot, the next step up, and we do 2 half pixel movements, which then enables us to scale up the information to 400 megapixel. Now, it's probably not going to come over very well on the presentation screen, but you can see the high-res shots on our website and download the file to look at if you wish, just to have a close-up look at the increase in resolution and color accuracy. As I say, quite a specialist camera, and we have lots of museum customers and so on, reproduction houses that use those. So moving on to the X1D. So looking at the X1D II, which was launched summer last year, literally a year ago. With that particular camera, obviously the X1D Mark I had been launched in 2016, and the intervening period, we had a lot of feedback from users, along with obviously the changes we ourselves wanted to make. But there was a core set of technology in the camera and features that we wanted to keep. So we kept those, and obviously the most obvious one is the look and feel, the design. And then we updated the functionality in terms of platform and so on, which I'll go through in some detail as we go through, compared to the original camera. So we're going to work our way through those changes. Outwardly though, pretty much the same looking cameras, obviously slightly different color, and the biggest change probably looking from the rear of the camera would be the size of the rear display and probably the size of the eyepiece cover. Weight-wise, even though we added additional functionality in the camera, including building in the GPS, we've managed to keep the weight pretty much where it was for the original. So no extra weight, even though there's more functions and features built in. And if you look at it compared to the, should we say, the classic design, say H6D, the Phase 1 IQ3, that type of thing, so the classic medium format body, much lighter. And so therefore, if you're carrying it around for a long time, typically out and about on a location or a travel type shoot, then you're really going to notice that difference if it's on your shoulder. So the core points were compact, lightweight, mirrorless design, dust and weather sealed. You know, the buttons, dials, even the lenses themselves have a rubber seal in the mount so that when you match them up to the body, that physically seals that lens body interface. Metal body design, metal everything, to be honest, as much as we possibly could. Hand grip, we kept the same. We didn't really change that at all because the feedback had been very good. Material was slightly improved in terms of holdability in different climates. But in terms of the look and size, we left it as the original one. Now, looking at the Hasselblad user interface, as I sort of said earlier on, we designed it to be very straightforward and simple. So touch screen with drop-down menus and values. So it's very easy to select the aperture or the shutter and choose from those values. If I'm on preview mode, I can double tap to zoom into 100%. I can swipe to the next image. I can swipe up and down on this particular display. So it's really straightforward, just like a smartphone. Very simple, clean layout, very few buttons and dials, simple to use. Having said that, if it's, you're wearing thick gloves and you don't particularly want to touch the screen, the two dials, front and back, allow you to change the main functionality, and including the buttons on top, you can change everything from white balance to aperture, shutter, pretty much whatever you want there, it's there. So moving on to the heart of the camera. So it's a 50 megapixel CMOS sensor, 70% larger than your average full frame 36 by 24. But more importantly, the pixels themselves are bigger. So they're physically larger buckets, if you like, to collect the light. But a lot of the medium format companies use this sensor, the Sony sensor. So what are the differences in terms of how we implement this sensor? So during our production system, every single sensor is tested first to make sure that if there are any dead pixels, where are they? Any hot pixels? Equally, we calibrate it so that any input, so if I've got a signal coming into a pixel in the middle and I get XYZ signal, if I was to take another pixel on the edge of the sensor and give it the same signal, it should give me the same output. So we actually calibrate the output from each pixel to make sure that they're equal for a given input. We also then ensure that the sensor and the mount itself is parallel with the incoming image plane. So that way all four corners are sharp equally. You don't get one soft corner, etc. The output itself, when we process this, is handled by the Hasselblad natural color solution. So even though the output from the sensor is 14-bit, it goes through a 16-bit analog to digital conversion process. It's then mapped into Hasselblad's color space. And then when we do the transformations to turn it into, if you like, the Hasselblad look, the Hasselblad color, the data that gets read out then is true 16-bit or 16-bit color definition. So that combination of transformations and adjustments, as it were, is what led to us being awarded the DXO 102 score. So we're going to go back slightly now, look at the pixel size and noise. So if we take each pixel as a container for the light coming in, bigger container means more light. All electrical systems have a underlying level of noise, and therefore the difference between that level of noise and the amount of charge within the pixel is known as the signal to noise ratio. So that is what leads to the dynamic range of the system in terms of the sensor and conversion process. And if we look at that now, X1D II and that 50 megapixel sensor has a 14-stop range. In a nutshell, what that means is we can capture the bright highlights and open up, capture the detail in the shadows in the single shot. So we don't need to do HDR effects really, unless it's an effect we want. This particular original image was very, very bad in terms of very contrasty, burnt out highlights, the shadows are blocked up. And so by processing the image through focus software, we could then pull back the highlights and open up the shadows and still keep the detail without introducing huge amounts of noise. For most of us, that actually means that we can make it good when things go wrong with an exposure. So briefly then, Hasselblad's natural color solution, taking into account what we've just discussed in terms of pixel size, sensitivity, conversion process, and the color space in use. Hasselblad also has a particular look and feel, and right from the beginning, photographers that use the system said, look, we don't want to have to choose color presets like we do on other systems. We just want a simple setting for the camera that gives me a good result in every condition. And so that's why we designed the natural color solution. It's a single setting on the camera, which then plots all of your captured data into the Hasselblad color space. We then do the transformations with particular emphasis on making sure skin tones are accurately reproduced. And from a user's point of view, you don't have to do anything. There's no presets, no settings, anything. Once you obviously get that into your editing app, so Focus software, or if you finish there and you put it into Adobe Photoshop, the color will be very, very good. And then it's more a case of you tweaking the image to get your final feel and look, maybe with some plugins, etc. But the core image that you'll get from the camera will be very accurate color. Slightly analog stroke film look is what comes out. We don't overemphasize saturation or contrast. It's a very, very smooth sort of analog film style look. And most people like it. So moving on now to X1D II, and we'll compare where we can to X1D Mark I. So big change is the EVF. So we moved up to 3.69 megapixel resolution from the original's 2.36. Nice step up in resolution. A little bit of a more magnified view in terms of the optical system within the eyepiece itself. So we've got bigger resolution, but also, as we'll talk in more detail about later on, we've also upped the actual refresh rate of the display. So the original camera was 30 frames a second. We stepped up to 60 with the Mark II. So you've got faster refresh, higher resolution, and obviously a more, should we say, a bigger window effect in looking through with that 100% view. So the EVF, the new OLED EVF, brings better contrast, better sharpness, obviously. Color accuracy, reproduction is much better. And as I just said, the apparent image scale, that sort of window effect has been improved as well. Useful feature as well, menu screens can now be displayed in EVF. So if you're working in really, really bright sunshine and it's difficult to see the rear screen, you can actually bring up the basic menu system and make your selections through the EVF if it's easier. The rear display itself, this was one of the biggest changes. So we moved up to a 3.6-inch display compared to the 3-inch of the original X1D I. Size obviously is much bigger, but the resolution itself went from 920,000 pixels up to 2.36 megapixels. So a big step up in resolution there. So 24-bit color, and to be honest, much more improved accuracy of contrast and color reproduction on the rear display. Makes it easier to view as well, the screen itself in the bright sunlight, 100% view. If you then couple that with the faster refresh and the resolution, you've got a much nicer image to look at and work on. So currently, if I'm shooting in live view using the rear display, I can touch the rear display to select the AF point that I want to use. Unfortunately, at the moment, it doesn't trigger the AF, but that is a function they're looking to add in a future firmware update so that when you select your AF point, it will automatically focus at the same time. So if you're using the EVF, the rear display turns into a large touchpad. And again, the bigger size of the screen means it's much easier, depending on whether you're left hand or right hand, to be able to access that rear display. And again, you can choose which area of the screen you want to use as the touchpad. And that way, with your eye to the EVF, you can just use your thumb or your finger to move the AF point around to where you want it and then focus. The whole of the electronic platform, including the image processor, was replaced compared to the X1D I. Now, we had to do that just to be able to speed up data processing, being able to move data quicker to the storage media, and to process things like the AF data quicker. And so the consequence of that system improvement, should we say, the platform improvement, means the data from the lens and the AF parts of the sensor comes through to the processor much quickly. So therefore the feedback to the lens in terms of your in focus, out of focus is much quicker in terms of a quicker cycle. It also means we've sped up the maximum shooting rate and increased the number of frames that you can actually capture at that maximum rate before the buffer is full. And so 2.7 frames per second compared to 2, it's a small jump up. There is a limitation anyway from the sensor. So best case scenario, it's just over 3 frames that you would be able to get out. We also now have added full size JPEG. So the previous camera could do quarter size only, and you could only choose RAW plus JPEG. So now you can choose just JPEG or just RAW, or obviously a combination. The slight downside is if you choose RAW plus JPEG, because we're working on full-size JPEG and writing that to card, we're writing a little bit more data, so it takes slightly longer. So therefore, it's slightly slower than the original. But the main underlying point here is from a RAW shooting and recording point of view, slightly faster frame rate for longer number of frames before the buffer starts to fill up. Live view, as I said before, we've increased that. So we've increased the rate by 62%. And the biggest change really is that it reduces flicker in artificial light, but also makes the image look that much sharper in the EVF or even on the rear display. More importantly, we improved the camera startup time by 46%. That was one of the biggest feedbacks we had from users, that they wanted to be able to access the camera from cold much quicker. So we did that. The shutter lag, so from when you physically press the shutter to when the image is taken, has been reduced. And also the blackout time. So once the image is captured and transferred, being written to the card, the viewfinder then turns back on. So we've reduced that blackout time by 25%. Connectivity-wise, pretty much the same between the Mark I and the Mark II. So you've still got your USB 3 Type-C connector. The difference here is that with the Mark I camera, you couldn't charge the camera battery in camera. So you could support the battery by plugging into a tethered computer, and that would give you a trickle charge. But with the Mark II, you can actually plug the camera into the mains adapter or an external battery source or even a computer, and it will charge the battery in the camera. Tethered shooting wise, you can connect to your desktop Mac or PC and connect with Focus software. Alternatively, you can use an iPad Pro running Focus Mobile 2, which we'll talk a bit about later on. But again, you can shoot full RAW into an iPad. The SD card slots have been updated from a UHS-1 to a UHS-2, so that gives us a faster write speed, providing your card can support that, which again helps keep the buffer from filling up too quick and enables you to keep shooting continuously for longer. Audio sockets, so input output are there. The microphone socket is what's used for the release cord X connection. Wi-Fi obviously was on both cameras still the same. And as I said earlier on, the GPS module, which used to slot into the hot shoe on the Mark I, has now been built and into the camera body, integrated in. The actual GPS part of it is exactly the same between the two models. So we've got the external module has been built into the Mark II's body. Autofocus. So up to 117 AF points, 3 sizes of AF point. And again, on the rear display, when you've got the live view showing, using a pinch to zoom type effect, you can select between the 3 sizes. There's all sorts of overlays as well in terms of grids, spirit levels, and so on, plus all of the usual exposure information that you would expect in a camera display. So aperture shutter, remaining frames, exposure indicator, and so on, plus many other things that pop up depending on whether you've got a macro lens on and it's set to close-up only or distance only. So lots of extra information within the display there. Autofocus though, one of the biggest areas we get questions on is how does it work? There seems to be an awful lot of movement going on within the system. Because we physically use pixels on the main sensor for the autofocus function, we need to tell the lens to drive in a particular direction to see if it's going to increase the contrast on those adjacent pixels or decrease it. And so that is why when you press the shutter button to autofocus, you'll feel the lens moving backwards and forwards, generally pretty quickly. But what it's doing, it's physically going forward to see if it's getting better. But we need to go past the point of focus to know that that was the best focus point, and then it starts to go out of focus. So then the lens has to come back. So you get a little bit of hunting until it zeroes in. If there's a good contrast level within an image, then autofocus is generally pretty quick. If it's a really low light situation and low contrast situation, then you can get a little bit of an issue, taking a bit longer to focus. And obviously the camera itself has an AF illuminator built in, which can project a pattern onto a subject sort of up to 3 meters away for the lens to use to focus. So it will achieve focus for you. Tethered shooting. So as we said a little bit earlier on, Focus Mobile 2 app was launched for iPad. iPhone version will come out at some point in the future, but currently it's just iPad Pro. And its 2019 versions onwards, because they're fitted with the USB-C connection, which allows you to connect the camera USB-C to USB-C. There are some adapters you can use to enable you to use an iPad Pro, or an iPad Air, but basically we recommend an iPad Pro 2019 edition onwards. Traditional desktop app is also available for Mac and Windows, and then you've got the full desktop controls there to allow you to tether, shoot, and import your images. Flash. So the hot shoe is Nikon compatible. It will work with TTL. We don't support the group functionality, just the basic TTL single channel. We've tested with most of the systems out there in terms of ProPhoto air remotes and so on. Nikon Speedlights, some of the third parties we've tested, and we know they're fine as they're Nikon compatible, they should work, but obviously we've not done exhaustive testing on that one. An improvement summary then, if we compare X1D Mark I with X1D II, we can see the general improvements there in terms of startup time, blackout time, burst rate, resolution increases, and so on. But the second part of the table is also interesting. So power usage. Any device that's got a battery in it will take some power if you leave the battery in. We've reduced that draw when the camera is switched off by 70%. Standby power usage has also been reduced. So rather than switch the camera off while you're walking about, you can allow the camera to go to sleep, go to standby, and not have to worry about the battery draining. Small reduction in the live view power usage. The control screen itself, we've moved to a much bigger screen. So when you're on the menu screens and making changes to the functions and so on, the previews, that will use slightly more power, but obviously you're not really spending a huge amount of time on that. Generally, you're just shooting. Long exposure, so sensor power draw, shutter power draw has been reduced by 8.8%. So again, long exposures won't have so much of a drain on the battery. So about a month back or so, we launched the 1.2 update, and that brought on functionality that we added majority of it to X1D Mark I earlier in the year, but some things were specific obviously to Mark II, so I'll concentrate on those first. So video function, this was missing from launch, and we've added an additional function compared to the Mark I. So we've added 2.7K recording capability. There's obviously still the HD recording option there as well. The newer higher resolution allows us to capture just under 30 frames per second, 8-bit color, and an MP4. Now we use a letterbox area, 16:9 section of the sensor. So you can see the resolution there to 2720 by 1530 pixels, and gives us an equivalent image circle of about 50.25. So again, we take a letterbox area from the sensor. So focus bracketing, this feature's been asked for a lot. And the reason is that some shots, no matter what you do, you just can't get enough depth of field in a single shot. So imagine a landscape shot, you want everything from half a meter in front of you to infinity. Depending on the lens that you're going to shoot with, that's virtually impossible. If you're shooting close-up shots for product photography or macro shots, sometimes it's just not possible to have enough depth of field in one shot. And so focus bracketing allows you to shoot multiple images, stepping the focus point as we go here through a series of images, and then you can take those images and stack them. For that, you'll need to use Helicon Focus or Adobe Photoshop to physically stack up those focus bracketed images, and then that will then give you, when it's compressed down, one single image with the equivalent depth of field from front to back that you were after. So within the camera itself, that function has now been added to the drive mode. And you'll find a lot of functionality now is much easier. You don't need to go into the menus. If I go into the drive mode button, which is on the rear display, you've obviously got single, continuous, self-timer, interval, exposure bracketing, focus bracketing. So all of those make sense to be together. Once you select a particular item, so in this case, focus bracketing, you can see all of the actual information that you can change within that function. So focus bracketing itself will give you many options to control it, from the step size, the number of frames. Do you want to wait at the start? Do you want a delay between exposures? If you're shooting with flash, you might need to wait 1 second or so for your flash system to recharge. Do I want to start at infinity and work backwards, or close up and work outwards, etc.? So many options. And actually, we will be bringing a how can I say, another webinar specifically looking at focus bracketing to this sequence as we go in the future. Another one that's been added to both sets of cameras is image rating. So now you can actually in camera select whether it's a good shot, bad shot, so that when you then import those into Focus Mobile 2 or Focus Desktop, it's very quick and easy for you to then narrow down, okay, where's my best 10 shots? Oh yeah, here's all the 5 stars. Work on those first and then work your way through from there. White balance system has been updated. So you can now see full information about each preset in terms of temp and tint. A manual white balance option allows you to physically dial in the value, so a particular Kelvin or a tint value is allowable there. And also the picker tool. This allows you to pick an area on a captured image and use that as your white balance area. So imagine you were in a complex set and you have a mix of tungsten, daylight, various light sources mixed in. You might want to then use a grey card, take a shot of that, and then use the picker tool to actually capture a correct white balance. So that's the camera body and main functions done. But obviously that's great, but you need a good lens on the front of it. XIDII lens family itself, the lens range was built specifically for the X series cameras. From the initial 45, 30 and 90mm lenses, we've now built that up to 10 lenses plus a dedicated converter, and focal lengths from 21mm to 230mm. So hopefully something for everybody there. Here's a graphical look at the focal length coverage. So one zoom, so 35-75 there. The new 45p in terms of the compact lens, and then various other lenses, including the 80mm 1.9. So I'm going to take a look at some of the notable lenses out of that. So the XIDII 21 ultra wide, that's equivalent to a 17mm lens in full frame terms. So great in tight spaces, architectural photographers, interior photographers, and so on. Or for those wanting sweeping landscapes, it's fantastically wide. Fully corrected, sharp right into the corners. I think you'll be surprised, even wide open on this one. The latest lens that we launched in January this year, very compact and portable lens. So 45p f4. It's not a replacement for the original XIDII 45. It's in alongside, shall we say. Both lenses are optically very good. The 45p was designed to reduce the size and weight. So this allows us to then make that combination of camera body and lens even lighter, shall we say, than the original system. Optically, very good. Aspherical elements and so on, because we've had to compress the optical path. So again, though, you'll be very happy with the optical quality corner to corner. No issues there whatsoever. It's sort of a must-have lens for every photographer really that's got an X1D. The portrait photographers out there, they absolutely love this 80mm 1.9. It's a big lens, as you would expect, but delivers beautiful shallow depth of field, really allows you to isolate your subjects very, very easy. Again, it is a big heavy lens, shall we say, compared to some of the others, but actually with the result that it gives you, it's absolutely worth it. Beautiful effects. So to sum up here, just to give you an idea from the 21 through to the zoom at the bottom, I've listed here the full frame equivalents in terms of focal length. So as I said, a 17mm for the XIDII 21 up to the 178 for the 135 plus converter. So full range of the sort of standard focal lengths that you would expect. Now, the lenses themselves, they're designed to how you put up with a lot of heavy use, a long life, but they're designed to give you the highest optical quality, corner to corner. That way, you know, not just using a sweet spot in the middle and not worrying about the quality in the corners, but even shooting wide open, you should be able to get great results, sharp results. And so wherever we need to, we will use specialist glass, low dispersion, aspherical elements, and so on to make sure that the quality is good corner to corner. Material-wise, they're built to last. You know, metal bodies, electromechanical focusing systems for most of the lenses. The new 45P uses a system that's very similar to the H, a more mechanical system, but some people prefer that. And again, the lenses themselves are weather sealed, especially, you know, there's, as I said before, there's a rubber seal so that when you attach it to the body, there's a good clean seal there, so no water or raindrop ingress can get into that. All of our lenses have a central lens shutter. Now, there's two reasons for that. I suppose the main benefit would be flash synchronization, and you can synchronize flash with any speed, all the way up to 1/2000th of a second. You don't need to use any specialist, you know, high-speed flash modes or anything like that. It's just standard, select your shutter speed and shoot. That way you can actually access the full power of any flash unit that you're using, and it makes synchro sun work, that type of thing, a simple thing to achieve. Second reason is vibration. Normally when you have a shutter in a camera body, with the blinds moving up and down, you have an up and down vibration within the camera body. Putting the shutter in the lens, we have a radial movement, so literally out to the edges of the lens and back into the sensor. And because it's further away from the main camera body, none of that vibration gets transferred. The X system with the XH adapter also allows you to access to the H system lenses. So the 12 lenses we talked about before, from 24mm to 300, but also things like the HTS tilt shift adapter that can be used in conjunction with the XH adapter to enable you to access these other focal lengths. And that includes things like the 100mm 2.2, the 24mm, and so on. If you're a V system owner, you can also use the lenses on the XV adapter, again on the X1D. Now, you'll have to use electronic shutter with this. Obviously, they were manual focus anyway, and you'll have to select the aperture, etc., on the lens, and then the electronic shutter can be used in the camera body. You can also use the X-pan lenses, again through the X-pan adapter, mechanical aperture, manual focus, and then electronic shutter in the camera. So just to sum up, X system is designed to be a compact, lightweight system that you can carry around and not really realize you're carrying it. Very simple, very quick to capture and process your work. Coupling up with the smallest lenses that we've just brought out, it's a really lightweight solution for traveling around. So lightweight, perfect solution for travel, landscape, editorial. A simple app that allows you to check that you've got the shot you want before you move on, and to do some basic editing if you want. Once you then get back to base, you can transfer all of the raw files from your iPad Pro onto your desktop system, and any corrections or ratings or anything like that will then be transferred over, accessible within the Focus desktop app.